Hi, I'm Lindley Hitzerling. I'm here with Willie Tejada, who's IBM's General Manager of ISV Build Partners and Chief Developer Advocate. He leads a global business of building a connected ecosystem of ISVs, build partners, and engaging developers for IBM. IBM is one of the largest, most innovative companies in the world, and Willie's driving developers towards them. We're one at Aerospike. Willie, take it away.
Hey, Lindley, thanks. Thanks for that mouthful of an introduction. I want to thank Aerospike as well as the attendees actually here. It's a pleasure of mine to address Aerospike Summit 2022. It's the first time I've actually done this session, but I look forward to it. I want to share some of the experiences and observations that we're seeing within clients as they look to modernize their systems of record data, and how it fits in the hybrid cloud and AI strategy. And most importantly, how Aerospike fits in uniquely accelerating those particular journeys. Now, it's for those of you who have been quite a while actually in this industry, it's no mystery that a tremendous amount of information actually sits behind mainframes, especially in the systems of record particular area. Just a little bit of history, it's kind of interesting, but you'll get a sense for why this source of resource and data is still heavily unmined. Is that back in 1958, the first airline reservation system was done in collaboration with IBM and American Airlines. It was known as the SABRE system. A lot of folks basically still know it as that name. And it stands for Semi-Automated Business Research Environment. Now, state-of-the-art back in 1958, I think the system actually went live roughly in the early 1960s, could actually process about 84,000 telephone transactions per day. Now, put that into context. Today, IBM announced, or recently IBM announced, an IBM Z mainframe can process 300 billion inference requests per day with just 1 millisecond of latency. Now, we're going to talk about that level of scale and specifically how Aerospike can actually help in that particular area. A lot of the data dialogue has been about the explosion of data, and much of that has been focused on the end-user-driven content or user-generated content, primarily due to social media. And when you really think about it from that standpoint, there's still an explosive level of growth in that area, but there's a tremendous amount of growth in traditional systems of record data that sits in the back office inside of these mainframes, which still run over 50% of enterprise applications in regulated industries. So keep that in mind, 50% of enterprise applications in regulated industries. And this data is not going anywhere. Again, another interesting note just in relation to the mainframe is that let me remember this gentleman, Stuart Alsop from InfoWorld, editor-in-chief, back in 1991, had predicted that the last mainframe will be unplugged on March 15th, 1996. And then he came back in 2002 and he made a statement that said, it's clear that corporate customers still like to have centrally controlled, very predictable, reliable computing systems, exactly the kind that IBM actually specializes in. Now, interestingly enough, it's exactly the type of system that Aerospike actually specializes in as well. So when you think about the mainframes and that source of systems of record data, keep in mind that there is 2/3 of the Fortune 100 that are utilizing mainframes, 45 of the world's top 50 banks, 8 of the top insurers, and 7 of the top 10 global retailers, and 8 of the top 10 telcos all have mainframes at the heart of their particular IT strategies. Now, this is a rich environment for Aerospike and its capabilities, but its utility can really be applied to what we are seeing overall in digital transformation. So, number one, let's take a look at what's happening in the digital transformation acceleration area from the IBM vantage point and RedHat vantage point. Primarily actually through our lens of what we're actually seeing through our technology stack and strategies rooted in Openshift. And I'll get back to Openshift and its approach in just a second. But if you actually ask most business leaders their take on digital transformations, while lots of them will tell you how much they've progressed, if you're really having that armchair visit, most will tell you that while they've made lots of progress, it's really been slow and in many cases fallen short of their transformation goals. And so I think one of the things to kind of drill down upon is, now why is that? Number one is hybrid is the norm. There's a mix of on-prem, public cloud, and even now multi-cloud environments. And heterogeneity is going up, not down. And with it comes complexity. Now, 76% of the users we talk to are utilizing 2 or more public clouds. And as I mentioned before, while they're still using 2 or more public clouds, only 25 to 30% of the enterprise applications have moved to the cloud. Now, this, again, is a tremendous opportunity for competitive advantage, because these applications are looked to be modernized and then take the data to leverage AI and unleash it across the entire enterprise. Now, when you think about that diverse computing environment, it also impacts their data and AI strategies, because they're dealing with exactly the same. We've seen clients go from the evolution of one hyperscaler to do their data warehousing, to do their analytics and AI, or a single SaaS provider approach, only to find that that doesn't provide them the flexibility they need to apply data and AI to the entire enterprise. And to service the needs and how they want to apply it to AI-infused automated business operations. Now, what we've seen with clients is that automation has actually gone from optional to gain some efficiencies to essential to compete. Now, part of that is the macro skill shortage as technology is moving so fast. We still have a skill shortage in developers and data science, with both those roles playing a really critical role as you try to apply AI-driven automation that can improve all these business results. Now, lastly, what we're seeing is in the area of security, whether it be Log4j, the vulnerability, or SolarWinds hack, cybersecurity is ever present. Now, I think a lot of that, especially with a hybrid cloud approach, is that the attack surface area is much greater. And so therefore, it's heightened that security actually is going to be an underlying foundational component as you actually take this hybrid cloud approach. Now, taking a look at where these workloads exist, the bottom line is hybrid cloud is the norm, multi-cloud is the norm. Enterprises will integrate, orchestrate workloads in multiple environments. And let me highlight just 4 factors that is driving this kind of new norm. Number one, or first, is history. You know, most enterprises are making decisions about their workload or their compute environment based upon where they are in their journey and what they're deploying, whether it be a systems of record or whether it be a systems of engagement. Whatever it might be, they're going to pick an on-prem environment, they're going to pick a cloud, they're going to pick essentially the environment that makes the most sense actually for them. And over time, one of the things that's happened actually as they go into this particular journey is that the need to actually meet them where they're at. And again, what you'll see through this hybrid cloud strategy and the way Aerospike actually approaches it is the ability to do exactly that, the ability to actually meet them where they're at. The second piece is the workload requirements that's actually factoring in and driving many things that we're actually seeing in the hybrid cloud norm, is that there's typically a 3-legged stool, the way I actually think about it. We've seen 2 of the 3 eras kind of really actually be put upon us. Number one was the original cloud environments was really a cost era, where it enabled us the ability to, for the first time, pay by the drink. Get what you use relative to basically what you need and right size that to the cost. Then we saw the explosion of social media and social networks really test the performance of the hyperscalers. So we saw that phase as well. Now, I believe that the last leg of these 3 legs, so cost, performance, and now security, is one of the reasons why we still have yet to see 70% of the applications actually move directly actually into the cloud-based environment. Because we've yet to actually see kind of a security and reliability phase that actually meets those particular needs. But ultimately, you want to actually get to these 3-legged stools, which allow you to take full advantage of what is the full cloud environment, which is based upon my workload, I want to move it to where I have the best value versus cost in terms of cost. When I need extremely high performance, I can move it basically where I need to. And when I need the highest security, maybe I'm going to keep things basically on-prem and allow that to actually happen. That also actually factors in, of course, to where your data is. The third area that's factoring in terms of the hybrid cloud norm is just the pure physics. Edge networking is becoming a big issue. And this idea of round trip time or low latency becomes a very big issue. It doesn't matter if you're really talking about real-time trading applications or a robotic manufacturing floor. Sometimes what you actually need is the ability to actually process and come to a decision tree very quickly, and physics basically will play a role. Now, lastly, is going to be law and these law frameworks. This idea of data residency. And it doesn't matter if you're talking about GDPR or you're talking about the California Consumer Privacy Act. The regulations around data and data sovereignty is imperative, and that your architectures need to deal with these legal frameworks and be able to navigate these issues, because they're likely going to be with us for a long time, and they're likely going to evolve at times. So you need that level of flexibility as well. And this is really basically where Aerospike and IBM can help provide flexibility with enterprises who are in what they're looking for. Around this, of course, is the data. And let's talk about that just for a second, actually, before we take a look at a particular example. While the data is growing in volume, the nature and the location of the data is also changing. Alongside the structured data, like relational and transactional data in SQL databases, there's been this tremendous rise in unstructured and semi-structured data, which has altered the data landscape. Rather than the data being stored in one fixed location where it can be controlled, easily managed, the data is literally everywhere. Now, I like to kind of think of it basically in three layers. There's the core, the large data centers where most of the processing and analytics go. There's also the edge, where the branch offices, cell towers, gateways actually are, and then, of course, endpoints, autonomous cars, laptops. But the bottom line is data is everywhere. And while relational databases remain still the most popular category of database, I think IDC had a report about 72%, more and more data engines are evolving to actually supplement the traditional relational databases so that they can actually deal with tasks that allow them to do these specialized tasks for things like large data sets that require low latency and potentially long retention time. And again, this is a lot of where Aerospike actually shines. Now, with that said, let's take a look at how a global brokerage firm deployed Aerospike to be a foundational component relative to their modernization architecture. Like many financial systems, they had any number of back-end systems of record. They needed to be queried as part of the client interface. The client interface needs were actually to go and query 20 plus systems that then needed to present a single view. And usually in an application like that, latency is a killer. Now, this particular brokerage firm had a number of key outcomes that they really wanted, and they set a very, very high bar. Ultra low latency of less than 1 millisecond for 99.9% of the transactions. Needed to be highly scalable and highly available. Oftentimes we're taking a look at these attributes associated with the mainframe. And then because of the dynamics of where the data actually resides and this fundamental issue about all the data silos, meeting those requirements are often very difficult. Now, along with that, they had to deal with some core issues. Time to market, talent and complexity being a lot of those, scaling and the associated costs. Now, just to give you a little background of how this architecture actually helps serve, is that the back office actually remained the same, but through Aerospike, they integrated and created essentially a middle tier that was an integration layer, as well as that ultimately served as their system of record for the intraday. They monitor about 13 million accounts in near real time. Now, just to give you an example of the task that they were actually trying to actually do is that one of their largest revenue producers was actually margin loans. Now, with 13 million accounts, they needed to actually handle that load. And at the same time frame, in real time, deal and manage the risk. When you think about risk, option expiration risk, margin risk, credit risk, all those things actually being part of the system requirements. With this architecture, they were able to actually manage the load, which is about no small feat, 13 billion queries against the Aerospike infrastructure a day. And the data needed to be stored in readily consumable format. And again, as I mentioned before, the goal was roughly that 99.9 of the reads were happening in less than 1 millisecond or less. Now, they started off actually with this particular tier. It represented, again, the first phase of what they're actually going to do. But what it really actually allowed them to do was then migrate to write applications, where the first application was primarily read, in a much more complex environment that required strong consistency and high throughput. The system would then update the backend systems through messaging utilizing MQ or Kafka. Now again, MQ and Kafka offering a level of choice. You can go security, you can go scale and high performance. And again, one of the important things basic about the infrastructure is, again, allowing that level of flexibility. Now, during the intraday, Aerospike is the system of record and provided an intraday operational data store. Now, the structure, while providing a lot of inherent capabilities, this idea of isolating essentially for troubleshooting, this middle tier of client-facing write capabilities are handled in this middle tier app layer. And it allows essentially this app layer to create a highly available, highly reliable middle layer tier that is at the application level that can also then be leveraged for future levels of applications. Now, as I mentioned before, the idea of a hybrid cloud environment is that there's going to be data everywhere. And what Aerospike has the capability of doing and what it allowed folks to actually do is pull together these multiple data silos, and in some cases, the historical systems of record data combined with streaming data to provide analysis and decision. So just that by itself basically allowed a tremendous amount of flexibility. Now, lastly, into this phase, they allowed essentially the platform to have the capability of doing new real-time applications. And as I mentioned before, the ability to actually deal with a large data set. I believe it started with roughly about 120 terabytes, growing to nearly 500 terabytes. And then they also had the requirement, again, of near real-time access, and then also a retention time requirement, which also factored actually into things like the cost factor in terms of its footprint. So you can see with roughly this architecture, this idea roughly of being able to maintain and simplify your backend mainframe system, but still provide the app flexibility and modernization actually to the client-facing applications is something really to actually explore. Now, the example that we actually have here is in financial services. But when you think about low latency, large amounts of data, it can be applied across multiple industries and multiple use cases, which I think Lemley and I will talk about a little bit actually towards the end of the presentation. But let me just spend a little bit of time, again, just emphasizing a little bit about the role of the mainframes, as well as then maybe come back to the role of OpenShift in this whole thing. And I won't, because we talk a lot about the mainframes, I won't spend too much time actually on it, only to actually just take a look at and suggest roughly that the mainframe footprint is increasing opposed to decreasing. And when you think about it, a lot of that is actually due to its role and its capabilities in the enterprise. You know, you have to remember basically that most of these mainframe systems operate with the idea of having 7 nines of uptime. So again, when you think about environments that we actually know of today, 7 times of uptime is what those requirements of those highly regulated industries actually have. And at the same time frame, it's also one of the reasons why we've only seen that 25 or 30% of mission critical applications move into the cloud. So as we actually build these highly reliable, high performance actually systems, and again, partnering with Aerospike, the ability to actually do so, this is where Aerospike can actually be utilized to unlock a tremendous amount of that system of record data. Now, keeping up basically with what's happening in the mainframe systems, the mainframe has evolved just as the industry has evolved. Number one was the adoption of Linux. In addition to that, the adoption of Kubernetes and the support of RedHat OpenShift inside of the Z16 platform. In addition to that, it was the addition of support of new languages and an emphasis on utilizing open source tools. So if you think about, again, the tooling and development environments that allow developers to use the DevOps tools and IDEs that they come to be most productive in, while still being able to leverage the Z16 mainframe capabilities, it's really shortened this talent, this gap that has been in the talent pool, because folks can actually use the tools that they use today, but also take advantage of these unique capabilities that come with the mainframe platform itself. Now, Aerospike is a foundation, can be a foundational component to any mainframe environment. The hot idea that it can be added as a component of the modernization reference architecture, especially when data sets are large and data is coming from many different silos, and when low latency requirements is required, is a perfect complement to what we're actually doing in the evolution of the hybrid cloud environment, with the Z16 platform actually just being one of the platforms that support that. Now, in addition to, again, just the inherent value of what Aerospike brings to the table, one of the things that IBM and Aerospike had partnered on is the development of a certified OpenShift operator. Now, let me just spend a little bit of time just talking a little bit about what that actually means and the role of OpenShift in this. This idea that OpenShift represents a abstraction layer, so that when you're actually taking advantage of a hybrid cloud and AI strategy that's rooted in OpenShift, you no longer basically have to be dependent or count on a single hyperscaler or on-prem deployment. And what we've seen by adopting this idea of OpenShift and the ability to actually build and deploy once in the environment and run anywhere is that it offers 2.5 times greater value from in comparison to a single vendor technology strategy. And there's primarily 3 value levers that actually come with it. Number 1 is business acceleration, just off the bat. When you think about it in terms of meeting you where you are in your journey, when you think about taking advantage, again, of teams moving quicker, faster, and ability to actually deploy. Business acceleration being one, and taking advantage of the other ecosystems, because it just doesn't limit you, again, to an AWS ecosystem or Azure ecosystem or Google ecosystem. You can take advantage of basically of all of them. Developer productivity, the build once, deploy anywhere has always been a bit of a holy grail. But with Kubernetes actually now being the industry de facto standard, it now actually allows us to realize the ability that Kubernetes is at its core. And what we've done with OpenShift is write the other infrastructure around it that allows it to have a consistency in terms of security and scale and automation and deployment. The third and last is really infrastructure cost, efficiency, and strategic optionality. As I mentioned before, when you kind of have this 3-legged stool, you have the ability to actually say, where should my workload run based upon cost, performance, or security? And your ability essentially to move that workload at a particular given time relative to what's important to your business is really a critical factor relative actually to that. So when you take a look at it from that standpoint, OpenShift has played a critical role with many enterprises as they take advantage of their hybrid cloud environments. And they're all searching actually to actually get that 2.5x added environment. Now, if you look at the layering of it, where OpenShift actually lies is in this abstraction layer between the infrastructure and the applications themselves. So by Aerospike building a certified operator, it gives them the opportunity, again, to deploy against IBM Z, the Azure, as well as the IBM and AWS infrastructures, as well as on-prem environments, giving them maximum flexibility as they deal with most of the clients who are typically going to have this hybrid and mixed environment. Now, it can go a step further. The operator structure can go everything from a range of capabilities relative to a simplification and optimization of the environment. It can be a basic install, or it can go directly actually into autopilot, where it can deal with scaling and auto-configuring. And then lastly, as you think about OpenShift being a common layer, also Red Hat Enterprise Linux or RHEL actually being a common layer as well, you'll find inherent talents as well as practices that understand this through the global system integrator layer. So when you think about it from that standpoint, the partnership between IBM and Aerospike, number one, provides a tremendous reference architecture foundation component as folks look at their modernization journey. Number two, it inherently actually addresses many of the attributes that are coming out of the hybrid cloud and AI landscape that IBM is seeing. And then last of all, it again allows Aerospike to actually take a look at where the folks basically are in their journey and not just start there, but also along that actually evolve with them. Now, in closing, before I get to Q&A, the explicits that we actually take a look at is this idea that when you think about mainframes, you're often talking about systems of records and data that actually have inherent reliability, performance, and security challenges. And oftentimes what actually comes with that is risk. So this approach and architecture that Aerospike has put together is kind of a better together strategy. That between the System Z architecture as well as what you have available with Red Hat OpenShift coupled with Aerospike, this idea that you can actually get to kind of first level of cache phase. You know, most applications that we run into is 80% read is the capability of most of those applications, and that 80% read capability, you can go first to a cache phase. And then just as we saw that brokerage firm, you can then implement essentially that middle application tier and augmentation phase for it actually to operate as the operational data store. And then overall, look at the end-to-end capabilities of Aerospike as a new system of record with its level of flexibility and its level of performance and its cost efficiency as you actually move forward. So with that said, Lenley, I think I'll open it back up actually to the floor and maybe even just ask you about some of your most interesting deployments. We did a brokerage firm here, but let's just chat about some of the other areas that you've actually seen some interesting deployments.
Well, hey, thanks, Willie. Great job. And so as you point out, this is a fairly general model where, the way I like to say it is, enterprises have, 30, 40 years of investment in business processes and regulatory compliance that they've built up in code. And a lot of that was done on mainframes for scale, in these larger institutions or enterprises. And we believe that we're a good match in front, to twin, if you will. It's almost a digital twin of the back office systems. And I don't like to say legacy. I like to say back office because we know those things are going to be around, essentially forever, as your stats point out. So we don't have much time, but there was one question from the audience, which I've got to ask you. It says, does OpenShift still require segmenting based on chipsets such as x86 64 versus ADM 64? And this is a test, Willie.
It does.
So
it does at the moment. It does at the moment. So
that's what I thought as well. But what I'll say, getting back to what we were talking about, it is this notion that there's a huge store of value in back office systems. I come from an enterprise resource planning ERP background as well as networking and databases and such, and those systems take 20 years to really get the coverage you need to run a company, and there's no return just to duplicate that for the back office. But in the customer engagement, in making new digital products at the edge that then have to tie back into those systems, we see this repeated over and over, where we can keep pace for large enterprises, for financial services people, for manufacturers, for telcos. We see this over and over again, where the large data sets, as you pointed out, the need for real time, the ability to scale based upon what one of our board members calls the non-linearity of the internet. When you open your doors to the world, you don't know if everybody's going to come all at once. And that's one of the key things. So with that, I'll say that, we're at our time. I want to thank you again, Willie, for coming here and being with us today. And it's always great to talk with you.
Fantastic. I hope folks get to explore some of these more detailed examples that you have left in the rest of your conference. And it's always actually great seeing you, Lonnie, and really excited about what Aerospike's doing.
Right. Thanks so much.